10 million bamboo poles lie buried beneath the surface of the Semarang-Demak Expressway in Indonesia. Why would engineers choose organic stalks over industrial steel to support heavy traffic? At first glance, the idea seems counterintuitive for modern infrastructure projects. But in reality, this natural material provides the necessary stability for reinforcing the unstable ground found in this region. Instead of relying entirely on concrete, the project utilizes the tensile strength of nature. But this is just the beginning. More than 1,500 skilled workers directly took part in installing the massive mat system. Because the construction site sits right next to the Java Sea, the soil remains extremely weak and challenging to build upon. One can notice how the grid of poles creates a stable platform to distribute weight evenly across the soft terrain. This technique turns a difficult location into a viable route. The process is only gaining momentum. It seems obvious to use metal for rigidity, but bamboo offers a sustainable and cost-effective alternative that adapts to the soft earth. The camera glides along the coastline where the reinforced roadbed takes shape against the water. It is visible how the structure integrates with the environment rather than fighting against it. Thus, the bamboo reinforcement secures the foundation for the road surface above. Tens of millions of cubic meters of water inundate the downstream regions of the northern coastal area of Java Island within just a few hours, causing dozens of floods every year. Why incorporate a traditional organic material like bamboo into a high-tech infrastructure defense project? At first glance, relying exclusively on heavy concrete seems the only viable option for a sea barrier. But in reality, the bamboo mat system offers a superior balance of durability and environmental safety, protecting thousands of households from the persistent risk of flooding. This dual-purpose initiative is widely known as the Semarang-Demak project. The entire route stretches 26.95 kilometers, acting not only as a vital transportation artery, but also as a formidable natural shield against the ocean. One can notice how the layout divides into two distinct sections: the Semarang-Sayung segment covering 10.64 kilometers and the Sayung-Demak portion spanning 16.31 kilometers. The total investment poured into this massive infrastructure amounts to 16.8 trillion rupiah. But this is just the beginning of the engineering scope. While the Sayung-Demak section was officially opened in February 2023, the Semarang-Sayung segment remains under active construction. It is visible how engineers are currently implementing the bamboo mat system layer by layer, with completion expected by early 2027. Transition to the next level of technical analysis. Compared to other ground stabilization technologies, the bamboo mat proves to be the most cost-effective solution available. The natural material integrates into the foundation without causing pollution, and it is sourced locally to avoid disrupting ship operations or the delicate marine ecosystem. Indonesia possesses 162 species of bamboo out of a total of 1,439 species worldwide, ensuring a steady supply of raw materials. Thus, the large-scale infrastructure project secures the capacity to operate sustainably for many decades to come. 3 years is the minimum age for a bamboo pole to be considered for construction. Only those with a diameter of 10 centimeters and a straight length of at least 8 meters are selected. One can notice the uniform geometry of the approved specimens. But this is just the beginning. Why is strict testing required before use? External inspection suggests the material is solid. However, these procedures ensure mechanical strength and long-term stability in seawater. Engineers apply the transverse tension test to the material. It seems simple to stretch the stalk, but in reality, this accurately measures torsional and tensile strength. The equipment gradually exerts force on the fibers. Transition to the next level. The perpendicular bending test follows immediately. it is visible how the pole curves under pressure to evaluate elasticity. This proves the ability to recover after deformation. The material is ready for use, 150 meters of width. This is the expanse the foundation reaches. After passing the rigorous inspection process, qualified poles are transported to the construction site. One can notice how they become the base for a highway built over the sea. Why drive bamboo vertically into the soft ground? At first glance, the method appears primitive, but in reality, it ensures stability. The material functions like stakes. Every 7 bamboo poles are tightly bound together to form a large bamboo pile. But this is just the beginning. These piles enter the soil at intervals of about 1 meter. As for the rafts, poles are arranged and tied, then installed by laying them on top. At each end, they are securely fastened to the rafts with ropes according to the original design. One can observe the structure locking in place. The process is only gaining momentum. Once installed, these bamboo mats gradually sink. It is visible how they become part of the coral reef, helping to reinforce the underwater structure without haste. 150 meters is the width of the surface, requiring immediate reinforcement. The underwater structure gains essential stability through this massive coverage area. The next step begins, laying the geotextile fabric. One can notice how the sheet slowly covers the bottom. Why use a separating membrane here? The bamboo mats seem dense enough to support the foundation, but the fabric prevents fine sand from seeping into the gaps between the mats. It is visible how the material acts as a load distributing layer. At first glance, the process seems simple, but in reality, it stabilizes the surface before the next layer of material is added. It gets more complex further on. The equipment gradually aligns the edges, ensuring sections are continuously connected to create a uniform and durable technical cushion. The base is now ready for the next phase, 6,000 meters. Exactly the distance the new foundation extends along the future highway to create a uniform and durable technical cushion. Why is such a specific combination of materials required here? The geotextile fabric layer is already completely secured, establishing the base. The answer lies in the need to create a solid foundation that is both highly load-bearing and flexible enough to adapt to the rough marine terrain. The next stage begins with the arrival of massive sand dredging vessels off the coast of Java. At first glance, sourcing fill material seems simple, but in reality, it requires the specialized trailing suction hopper dredger. This ship is equipped with suction pipes located beneath its hull, capable of reaching the seabed. It extracts sand and stores it in onboard hoppers for immediate transport. One can notice how high-capacity dredger ships pump sea sand over the entire bamboo mat system. The material is sprayed onto the surface of the bamboo rafts through a special conduit, covering an area of more than 150 meters. But this is just the beginning. The cycle repeats ceaselessly to build height. One layer of bamboo alternates with one layer of sand until reaching the 17th layer. Thus, the total length of the bamboo raft and sand foundation reaches equivalent to 6 kilometers. The massive structure settles, awaiting the next phase of the expressway construction. Vertical strips of drainage material pierce the soft terrain to shorten the consolidation time. Why do engineers use these conduits in the foundation? It seems that natural drying should be sufficient, but water within soil pores remains trapped inside without a specific pathway. These inserted elements allow moisture to escape quickly to the surface instead. But this is just the beginning. A sand layer above exerts compression pressure. One can notice how water is forced upward along the drains and discharged. It seems like a simple physical process, but in reality, it enables the soil foundation to stabilize rapidly. As a result, the consolidation rate increases several times. The project reaches the required settlement level in a much shorter time. the area is ready for the road surface construction phase. 4 distinct levels form the engineered structure of the road foundation system. Why replace the standard compacted soil with bamboo and sand? The subgrade usually consists of natural earth found on site. But in this specific project, the alternating organic and mineral layers act as the primary load-bearing foundation. At first glance, the construction process proceeds similarly to conventional expressways, but every layer serves a specific function. Workers place the sub-base course made of crushed stone to significantly increase load capacity. It prevents the underlying soil from being pushed upward under immense weight. But this is just the beginning. One can notice how the base course, composed of granular material or bituminous mixture, settles above the stone. It helps evenly distribute pressure from the road surface to the depths below. Finally, the surface course is applied as the layer directly in contact with vehicles. It consists of a precise mixture of bitumen and mineral aggregates. It is visible how the paver creates a smooth, durable, and wear-resistant pavement. Thus, the multi-layered structure is fully prepared to withstand the traffic load. 9,000 skyscrapers. This is the scale of the forest of steel and concrete that defines Hong Kong. Why does this ultra-modern metropolis still rely on organic grass poles for construction? At first glance, it seems archaic compared to global standards where metal scaffolding dominates. But without this flexible framework, the city's architectural maintenance would be nearly impossible. From the highways over the Java Sea to these urban canyons, the journey of bamboo evolves from a humble material into a structural pillar. Hong Kong boasts nearly twice as many high-rise buildings as New York and 3 times as many as Shanghai. Yet amid this dense landscape, one can notice scaffolding frames woven from bamboo surrounding the towers. This technique preserves a history spanning hundreds of years, defying modern industrial trends. Before the material reaches the site, it must go through a meticulous selection process. Only the finest poles meet the standards required for high-altitude construction use. The selected bamboo must be between 3 and 5 years old to ensure the fibers are dense enough. It is air-dried for at least 3 months to achieve maximum mechanical strength. But this is just the beginning. Durability allows each pole to be reused up to 3 times. If the pole becomes warped or loses flexibility, it is discarded immediately to maintain standards. This treatment process is the key factor that determines the overall safety of the entire scaffolding structure. One can notice how trucks transport the qualified poles to construction sites for deployment. Bamboo scaffolding wraps around buildings from the ground to the very top, forming an intricate lattice stretching high into the sky. It is visible how the lattice scales the facade, remaining lightweight yet strong, provided it is assembled with absolute precision. 2 types of bamboo are commonly used to balance weight and stability. Thick moso bamboo is selected for load-bearing sections, while smaller guadua or golduke bamboo handles the frame connections. It gets more complex further on. All joints are manually tied using nylon knots. This skill takes years to master, as metal supports are added only in certain areas to increase stability. Thanks to its flexibility, the material wraps around balconies, curved facades, and even suspended architectural structures. The camera glides along the complex geometry of these temporary cages. While scaffolders once climbed dozens of stories without protective equipment, today, Hong Kong law strictly requires safety harnesses, helmets, gloves, and non-slip shoes. Everything only gets more complicated. Although durable, bamboo is not uniform in size or shape like steel pipes. This makes construction work require extremely high craftsmanship to align the irregular poles. Every joint is tied manually by hand, and even the smallest mistake affects the entire structure. The demanding techniques have caused the art to gradually disappear in many regions. However, in Hong Kong, This green material is still celebrated as a symbol of craftsmanship and Asian identity. The intricate grid supports the city's vertical ambition. Thus, the bamboo fulfills its role before being dismantled for the next cycle. The 21st century regards bamboo as the green material of the modern era, thanks to its superior mechanical properties and rapid renewability. Why compare organic fiber to heavy metal? The materials appear unrelated to the naked eye. Yet, with tensile strength greater than steel, bamboo withstands high loads while remaining lightweight and easy to work with. One can notice its natural flexibility under stress. But this is just the beginning. In contrast, steel production generates a massive amount of greenhouse gas emissions. This occurs because the process requires burning large quantities of fossil fuels, such as coal and oil. At first glance, steel seems like a standard solution, but in reality, not every country has the capability to develop a large-scale industry. This significantly increases both financial costs and the overall environmental impact. Bamboo offers a different path, being locally sourced and maintaining a low cost. In tropical regions, it is visible how the plant grows quickly and is easy to cultivate with minimal maintenance. Transition to the next level. The material proves highly sustainable compared to industrial options. Therefore, bamboo remains a symbol of sustainable architecture for the future. Countless tons of single-use plastic waste are gradually being displaced by a material with a unique longitudinal fiber structure. Today, bamboo is not only used in heavy construction, but has evolved into an environmentally friendly foundation for a wide range of consumer products. Straws, chopsticks, toothbrushes, cups, spoons, baskets, and decorative items are entering the global market. At first glance, a single bamboo straw or pair of chopsticks seems insignificant, but in reality, they play a vital role in reducing the severe pollution caused by plastic. But this is just the beginning. Why is the production process considered so energy efficient compared to synthetic manufacturing? The raw material requires minimal processing steps to become usable. Workers cut, boil, and dry the stems, preserving the natural strength without heavy industrial refining. The material undergoes polishing to achieve a smooth finish suitable for daily use. One can notice how the surface texture becomes uniform before the antibacterial treatment begins. Manufacturers employ natural methods such as steaming or soaking the items in bamboo vinegar to ensure hygiene. As a result, these products are not only safe for human health, but also become fully biodegradable after disposal. Many small workshops have grown into sustainable production chains, creating essential jobs for local communities. Because of this versatility, bamboo serves as a symbol of the green circular economy, connecting nature, people, and the future. It does not end at this stage. A significant portion of bamboo waste travels to furnaces to produce bamboo charcoal. This substance possesses excellent odor-absorbing properties, making it effective for deodorization in cars or rooms. It is visible how the porous material also acts as a filter in water purification systems. Therefore, everything is utilized, with different groups taking charge of each specific stage. During the production of charcoal, a byproduct known as bamboo wood vinegar is also created. This liquid can be used in medicine or applied as a natural termite repellent. The natural cycle is completed without leaving useless residue. One specific natural defense mechanism works as a powerful termite repellent, ensuring the longevity of the fibers. Why was bamboo regarded for centuries as a humble material suitable only for thatched roofs and small village bridges? At first glance, the lightweight stalks appear fragile compared to stone or concrete, but under the technical guidance of humankind, its structural value has undergone a complete redefinition. The plant transforms from a slender element into a heavy-duty industrial component. The application of this resource expands steadily, One can notice how bundles of bamboo form the foundation for roads, stretching hundreds of meters out to sea. It serves as the primary scaffolding grid that supports the construction of skyscrapers in vertical modern cities. The technical achievement lies not only in the tensile strength of the fiber, but in the engineering proof that such a simple material can withstand extraordinary loads. It seems like an archaic choice in an age dominated by heavy machines and complex alloys. But in reality, bamboo demonstrates that innovation does not always require discovering new elements. It often arises from analyzing familiar resources through a prism of advanced adaptability. This flexibility proves that the plant represents more than just a static piece of cultural heritage. And this is not the limit. Bamboo establishes itself as a critical material of the future. It remains in the production cycle as a durable symbol of sustainability and respect for nature in the modern industrial world.